Welcome back to CIT 157 Module 5-2. In this module, I will talk about how people standardize networking rules. Then I will explain OSI 7 layers model and Internet model briefly. As I have mentioned before, this is summary of your reading. Now, let's talk about network standard. Standards are necessary in almost every business and public service entity. Network standards provide a fixed way for hardware and or software systems, different companies, to communicate. They also help promote competition and decrease the price. There are two types of standards making process. One is formal standard process called de jure, de jure. It is developed by an industry or government standards making body like HTTP, HTML, IP. Another one is de facto. They emerge in the marketplace and are supported by several vendors. So they are lack official backing by a standards making body. An example is most PC use MS Windows family as their OS. Specification is the first step in standardization processes. An organization may develop the nomenclature and identify the problems to be addressed. Then they will identify solutions to the problems and choose the optimum solution. Then industry will accept it as a uniform solution. There are several major standards bodies. ISO is International Organization for Standardization. ITUT is International Telecommunications Union Telecom Group. ANSI is American National Standards Institute. IEEE is Institute of Electrical and Electronics Engineers. IETF is Internet Engineering Task Force. You need to recognize these bodies. For network communication functions, there are two approaches. Single-layer implementation approaches networking with one large components. This would be complex to understand and implement. Multi-layer implementation approaches networking with breaking down into smaller components. It would be easier to implement. Currently there are two widespread multi-layer network models. One is OSI, the Open Systems Interconnection, 7 layers model by ISO, International Organization for Standardization. It is de jure type of standards. It is a conceptual model that characterizes and standardizes the internal functions of a communication system by partitioning it into 7 abstraction layers. For networking there is another approach. It is Internet model, which is called as TCP model. It is de facto type of standards. It was based on a 4-layer conceptual DARPA model, which named after the US government agency that initially developed TCP/IP. In OSI 7-layer model, Layer 1 physical layer defines how individual bits are formatted to be transmitted through the network. Layer 2 data link layer deals with message delineation, error control, and network medium access control. Layer 3 network layer is responsible for making routing decisions. Layer 4 transport layer deals with end-to-end issues such as segmenting the message for network transport, and maintaining the logical connections between sender and receiver. Layer 5 session layer initiates, maintains and terminates each logical session between sender and receiver. Layer 6 presentation layer formats data for presentation to the user, provides data interfaces, data compression, and translation between different data formats. Layer 7 application layer set of utilities used by application programs. In OSI 7-layer perspective, ascending layer wraps the incoming, from upper layer, message with its own envelope. Internet model combines top 3 layers of ISO 7-layer model into one application layer. Actually there is ambiguous borderline among those top 3 layers, application layer, presentation layer, and session layer, in ISO 7-layer model. This is an example of sending email in perspective of Internet model. In application layer it add SMTP, simple mail transfer protocol, header in the message. Then in the transport layer, it break several pieces and add TCP, transmission control protocol, headers. One of TCP headers is like this: part is 1 out of 3, next one is 2 out of 3, and the last one is 3 out 3. So when the other computer who receives the email assembles them using TCP, that time, if there is any missing portion, it sends a request only for that missing portion. In network layer, it adds IP header. There should be destination IP and source IP. This IP address is used to find the destination network. In data link layer, it adds data link header. In this example it adds Ethernet header. It indicate where the frame starts and where it ends. It also have error checker. It also has next device physical address. Using physical address, it moves to the next node. Actually at the end of the travel, it uses IP address to get the destination network. Inside the network, it uses physical MAC address to reach the destination. In physical layer, it changes the data into electronic signal and sends it. This is an overall picture. I have explained this with the image in previous slide. This is comparison of OSI 7-layer model and Internet model with groups of layers and examples. In network layer model, layers allow simplicity of networking in some ways, so each company may develop new software that fits each layer easily. Because there are standards to follow, matching layers communicate between different computers and computer platforms. However, some may say they are inefficient because they may require too many software packages and packets. As you know, networking protocols are sets of standardized rules to define how to communicate at each layer and how to interface with adjacent layers. This shows protocols for each layers based on Internet model. This describes protocols in the perspective of OSI 7 layers model.